Today, I'll introduce the usage of series resonance reactors produced by Wuhan UHV. Actually, many industry peers are familiar with connecting reactors in series. However, regarding the series parallel connection of reactors, especially the combined configuration for cables, some might not be entirely clear. For example, when testing a 10 kV cable, first, check the rated voltage of a single reactor unit. If the rated voltage of a single unit meets the cable's withstand voltage level, then a single reactor is sufficient. Suppose this single reactor unit is rated for 27 kV for testing a 10 kV cable. As per national standards, 10 kV cables are typically tested at 17.4 kV. Therefore, a single reactor unit is adequate. If the cable length requires it, we need parallel connection. We are now dealing with a combined load configuration similar to a 35 kV setup. The test capacitance we're assembling now is around 0.6 microfarads, which is equivalent to a 35 kV test cable with a 400 square millimeters cross-section and 3 kilometers length. Regarding reactor combination, as mentioned earlier, one reactor unit is 27 kV, so 2 units in series become 54 kV. The next step involves parallel connection. You can see this parallel configuration uses a 2-series, 3-parallel, fully parallel approach. What does 2-series mean? It means connecting two reactors in series. After series connection, parallel connection begins. Connect all low-voltage terminals together, and connect all high-voltage terminals together. After connection, suppose the single reactor unit is rated for 2.5A. Then the series connection becomes 54 kV at 2.5A. With 3 groups in parallel, the maximum high voltage current reaches 7.5A. This corresponds to the specifications of Wuhan UHV's 67.5 kV to 27 kV reactor units. Of course, there are other specifications available, but the combination principle remains the same. We first meet the voltage requirement, then address the current requirement. The current can be estimated using the resonance calculation tool on Wuhan UHV's WeChat official account or website. Using this tool, you can roughly determine the test capacitance value. Through the app, you can calculate the required high voltage current. Based on this current, you can determine how many reactors to connect in series and/or parallel. The overall principle is, first satisfy the voltage, then satisfy the current. That concludes today's introduction to reactor combination methods. Thank you for watching.